Hello Year 4, welcome to your Friday maths lesson. We're going to be revisiting efficient multiplication methods again today. So if you bear with me, I'll just share the flip chart with you. Okay, so just for our warm-up, to get our brains working, I'd just like to have a little go at this question for me, please. So it says, James has £245. He gives £50 away to his dad and £25 to his sister. How much money is left? And then I've drawn you a bar model at the bottom to help you to work out what sort of sum that is. So if you think about our rucksack instructions, so we read the problem, we understand it by underlining the important information, we work out what sort of calculation we're going to do. And then we solve the calculation, and then we answer the question, and finally we check. So if you'd like to pause the video here and just do that, and we'll come back together in a moment. Okay, so hopefully you've had a go at that. If we have a look at it together quickly before we begin our main lesson. So James has £245. That's the biggest amount of money that we're going to be dealing with, because that's all the money that he's got. So I know that I need to put that in the top box there. I don't need to worry about the pound signs when I'm working out, as long as I remember to add them on when I answer the question at the end. So I've read the question. If I underline the important information or highlight the important information here, it's important that he has £245, and I've popped that down here in the top bar of my bar model. And then he gives away £50, and that's important. It doesn't matter that it's James that's giving it away or who he's giving it to, but it does matter that he gives £50 away, because that helps us to understand what sort of sum it is. And then he gives away £25 to his sister too, and that's important. It's £25, but again, it doesn't matter that it's his sister, it could have been his brother, auntie, whoever. And then this is the important bit, isn't it? How much is left? So those words there, we've read our problem, we've underlined the important information, and the words that we've underlined have helped us to understand what sort of question it's going to be. So James has an amount of money, which we've put here, and he's giving some away. We want to know how much is left, which suggests that it is going to be a takeaway sum. So in the boxes down here, we know that he gave away two different amounts. So we're going to have sort of two steps, two parts to this question. So he gave away £50 to his dad and £25 to his sister. So I'm going to put those in there. And going back to our efficient method yesterday, we can do this in two ways. Either we do 245 and we take away £50, and then from our answer, whatever our answer is, we take away £25. Or we can add those two amounts of money together, and then we can take them off all in one go. So it's up to you how you did that. It doesn't really matter which way around you do it. So I would maybe take off the £25 and say, right, that leaves me with £220 if I did it as a column subtraction. And then I'd take off another £50 off of that, and that would leave me with £170, I hope. You can correct me if I've mentally worked that out wrong quickly. So we would either add those two numbers together and do and then take them away from that amount, or you take one number away and then take the other number away. Okay, we're not going to dwell on that too long, because we're going to move on to our efficient methods lesson for today. So yesterday we talked about what was the most efficient way of working out multiplication questions, times in two-digit numbers by one-digit numbers. And if you remember, I explained that efficient meant the most straightforward way, the easiest way, and what maybe the easiest way for you may not be the easiest way for somebody else. So an efficient method depends on who is doing the method to start with. So we're going to have another go today. It's just more of the same as yesterday, to really embed that knowledge and make sure that we know what we're doing. So there are 8 classes in school. Each class has 26 children. How many children are there altogether? So this is like a word problem, like in our warm-up. So we know that there are 8 classes, and that's important. and each class has 26 children, and we want to know how many all together. So this is going to be a multiplication sum. So we've got those 26 children, and we need to multiply those by the 8 classes that they are in. So the sum is going to be 26 times 8. I'm going to show you some different methods, just like yesterday, that you could use to work it out, and then you can have a go at working out some yourself. So the first method is our kind of trusty method that we should be the most familiar with. And this is partitioning or grid method, some of you might know it as. So we take the 26, the 2-digit number, and we just chunk it, we partition it, chop it up, however you want to describe it, into the 10s and into the 1s. We work them out separately, and then we add the answer together. So we say, here's the 20 and here's the 6. Or if we want to look at it in the grid here, like we're used to, there's the 20, there's the 6, and then we're timesing each one by 8. So if we're looking at the grid method, because that's the same as the way we did it yesterday, if we ignore that 0 for the moment and just imagine that that's a 1, as in the 1s column, so it'd be 8 times 2, which is 16, and then we have to multiply that by 10 because we kind of covered up and ignored the 0. So put that 0, put it back on by multiplying by 10. So that's that one. So 8 times 20 is 160, which is the same as what they've written up here. And then 8 times 6 is 48. And then we have just added those two numbers together down here in the column addition. So 0 add 8 is 8, 6 and 4 is 10. So we pop that 1 underneath. And then 1 and nothing would be 1. But don't forget that little one out on the doorstep. He needs to be included too, or she. And so 1 and the 1 on the doorstep makes 2. So our answer is 208. And that's exactly the same as what we've done here. So that's our first method, and our kind of tried and tested. If you're not sure, start with that one. That's a really good one to use. And sometimes you kind of have to use that one because the other methods don't work as well. Then some of the others we talked about yesterday. So we did this one where we said that we could break up that chunk, that partition, that number a little bit more. So we've got the 10s there. We've done it, instead of doing 20 all in one go, we've done 10 and then another 10 and then the 6. So that's 10 and 10 and 6 makes up the 26 look, and we're timesing each one by 8. Again, this might be easier for you. It depends. If you find adding more easy than your times tables, then this is quite a good way to do it. Obviously, if you have too many lots of 10 to add, it becomes quite tricky adding some, doesn't it? So it's up to you whether you think that way is easier for you or this way over here, doing the 20 altogether. And then the last way we talked about briefly yesterday as well, which is down here on my steps to success. Round the number and then subtract the difference. So we need to do 8 times 26. That's a bit hard. So here we've done 8 times 30. And again, I've ignored that 0. I've done 8 times 3, and I know that's 24. And then I've multiplied that answer by 10 to take account of that 0 there. And then because I did 8 times 30 instead of 8 times 26, that is 4 too many groups, isn't it? I had to add on an extra 4 groups of 8 to make that up to 30. So I need to then take that off. So I do 8 times 4 is 32. So that's how many too many I added on. I added 4 extra groups than I should have done. So I take those off, and then that gives me the same answer. Okay, like I said yesterday, if that baffles you and confuses you, don't worry. Just stick with our trusty grid method. But some of you might like to have a little play around with doing those, because sometimes they are quite quick to do that way, depending on the sum. So if we move on, I would like you in a moment to pause the video, and I just want you to have a go at doing these 3. And I'd like you to use our grid method, our partitioning method, to do these. So if I help you to put the numbers for the first one into the box, then you can get going on your own. So it's a timesing one, and we're timesing by 7. And then we're splitting up that 16 into the 10s and the 1s. So in this number, there's 10 in the 10s column. I'll put them in the box in a minute. And there's 6 in the 1s column. Let me just move those, because it's all gone a bit wrong on the calibration of my laptop. As you know, it does that in school too, doesn't it? The same problem at home. There we go. So we've got our 16 is up here, the 10 there, and the 6 there, and then the 7 there. And then you multiply the 7 and the 10, and then multiply the 7 and the 6, and then add them together. Okay, and then do the same for this one and this one as well. So if you pause here and do that, and we'll come back together again in a minute. Okay, hopefully you've had a go at those now. In your maths book, I didn't say that at the start, but obviously you've got your curriculum, your maths books, haven't you, at home with your squares and things, and then that'll make it much easier when you're trying to do all your column addition and stuff if you use the squares properly in your book. So remember 1 digit in each square. Okay, so we'll start off 7 times 10. That's nice and easy. We can do that one. 7 times 10 is 70, so we'll pop that in there. And then we've got 7 times 6 to go in here. And again, I know that's 42. If you don't know that's 42, I would suggest you write out your 7 or your 6 times table, doesn't matter which, just to make sure you haven't made any mistakes and that you get the answer right. And then we're going to add them together. These are a bit tricky to do on the typing them. As you know, in school we would write those, wouldn't we? Or I would write them with my pen on my whiteboard, but I'm going to kind of have a little try like this. So we do 0, oh, and it's an add. Give me back my pen. There we are. So going to do 0 add 2 is 2, a very shaky 2. And then 7 add 4 is 11. So I'm going to put my, like I've got a 2-year-old writing here. There we go. So my answer is 112, okay? And then we're going to do the same for the others here. So we need to think about how we're going to partition that number. So we're going to do it into the 10s and the 1s as we've been doing all the way through. So we've got 30 in there and 4 in there. Multiplication, so I don't have to put that in there, but it helps me to remember that I'm multiplying, timesing, and not adding or anything else. And the 6 in there. Then I'm going to do 6 times 3, and because the 0, I know what 6 times 30 would be too confusing to work out, so just ignore that 0. 6 times 3 is 18, and then I'm going to multiply that answer by 10 to make it 180 to take account of that 0 there that I took off. And then I've got my 6 times 4 is 24 here, and then I need to do a column addition to add them together. So I've got 180, add 24. And I have to see if I can write this sort of backwards. So 0 and 4 makes 4. And then 8 and 2, I have to try with my pen. 0 and 4 makes 4. 8 and 2 makes 10. So I'm going to put the 1 underneath. 0 there. And then I've got 1, and then the little one on the doorstep, don't forget him. So that's going to be 204, okay? And then for my last one, I've got 27 times 4. So once again, I'm going to divide that up, and I'm going to do 20 and 7, because that's my 10s and my 1s this time. So you should have it like that. And then again here, you might know what 4 times 20 is. And you might just know that it's 80, or you might do 4 times 2 and then multiply the answer by 10 to include that 0. And then 4 times 7 is 28. And then we can add those together. I'm not going to make you painfully watch while I try and do that again as a column addition. So I'll just add those together. I can do that in my head. I know that 80 and 20 makes 100, and then 8 more. So it's going to be 108. So I can just say equals 108. And that's quite an important lesson as well. If you can work it out easily in your head, there's really no need to do a column addition if you don't need to do one. Okay, so those should, hopefully you got those right. If I've made any mistakes, then you can. Okay, so it says Rosie uses base. This is just different ways of showing lots of 10 there. So we've got 20 there. So that's 3 lots of 20, isn't it? It's there as well. So she's done the same thing. She's times 3 there. So that's just showing the 6. And actually that's exactly, we'd put 20 here and in, and then we'd add them together. In the same way, Rose, do that one, add them together. So it's just, that's just partitioning again. That's exactly the same, our partitioning way, grid, because that's quite an easy way to see them. Thank you. To pause the video, have a go at working out these. You can either do them the part whole model or both. and work out what the answer. Okay, so you've pressed play again, so I think you may have finished. I'm not going to go through all of these because it will take far too long on our lesson, but I'll go through a couple just so that you can see what we're doing. So exactly the same before if we put them into our grid method. So it would be 36, and we're timesing by 3. Times up there to remind us. And then, same as before, 3 times 30, or 3 times 3, and then multiply it by 10, up to you. So that's going to be 90. And then 3 times 6 is going to be 18. Let's put that one in there as well. And then we can add those together. And the same as before, I don't need to do a column addition to add those together. So I've got 90, add 18, makes 108. You could do the same for the others. Now, if you wanted to do this one, set it out like Rosie's one, it would be 30 times 3, and then 6 times 3, and then you would add them together. Okay, so it's just another way of getting you to just see it in a different way. Sometimes it's presented in a different way, and we have a bit of a panic, but it's just so that you recognise that these two methods here are the same as this method. Really, it's just set out in a slightly different way. Okay, so you can either use a calculator to check you've got the answers right to those, or you can ask an adult if you're lucky enough to have one around who you can ask. This is going into the gold task now. Sorry it doesn't look very pretty, but I wanted it to be as big as possible on the screen. So I'd like you to pause the video in a minute, and I'd just like you to have a think about other ways that you could do these sums. Okay, so let's look at the first one together. It says, Jack says to calculate 29 times 5, you could calculate 20 times 5 and then 9 times 5. And so that's the partitioning way he's talking about, isn't it? That's the first way on our steps to success up there. So I want you to have a little go thinking about the second way on our steps to success as a bit of a hint. I want you to have a little go and see if you can try and work them out in another way. So for the first one, I would say use the grid method. And then after you've done that, another way of working it out might be to do 30 times 5, because 29 is nearly 30, isn't it? 30 times 5, so you could do 3 times 5 is 15 for your 0. And then you could take away, I was only asked to do 29 groups of 5, and I've done 30. So I need to take off one group of 5 from my 150. So I can work out that that is 145. So that could be another way that I could do it. Now, I would like you to have a go at the next two by yourselves. If you are really, really stuck and you're struggling to do it this taking away way, then that's okay, and that's not a problem. Just work out what the answers to all of the questions are using the grid method, okay? And the rest of you are feeling like you want to have a go at the adjusting one. If you have a look at this one's 99, so you could round that up to another number, because 50, and you have to think about if there's a different way, and then we'll come back and have a talk. Okay, so hopefully you've at least had a go at working out the answers to these sums using our partitioning grid method way. And some of you might have had a little go at this one and decided to try doing, instead of doing 90 times 8 and then 9 times 8 and adding those together, which is what Kelly says, that's Kelly's way. You might have said, right, okay, I'm going to have a go at doing 100 times 8 because I'm super good at multiplying by 100, and I just know that's 800. If only it was as simple enough to stop there, but it's not, because obviously we've added one group too many, so then we'd have to take off a group of 8, wouldn't we, to make that correct. So we then need to take away 1 times 8, which is 8. So we're going to take away one group of 8, which is 8. So we need to do 800 to take away 8. Now, if you can't do that, you could do it as a column subtraction if you wanted to. But I know that it's going to be 700 something, because I'm only taking away 8 too. Okay, so hopefully you got that answer. Hopefully you got the right answer. Bit of a headache this afternoon with some 6. It's simple. You just multiply, isn't it? So we can do 5 times 6, and the answer will be 300. And that does sound like whether we can think of a different way to do it. There are other ways that you could do it. Now, it's all is to times that by 50 times 6. You could and say, well, I know 50 to get to 100. I can't do a division sign on here, so I'm going to do it like one of those. 600 by 2 is 300. So divided in half is 2. So half of 600 is 300. Okay, as well. And that's quite a good way. You might think that's really silly, multiplying. When you get to do decimals and things, sometimes it's really multiplying by much bigger, harder numbers than by 100 and then half it. Lockdown, Mrs. Ogletree. And that's not the most efficient way for you then, is it? You could just do it with our grid of those. Now, if you've got someone there to talk to them. If about how could Katie do this in a more efficient way? She's fine how she's done it. She's got the answer right. That's a really big sum and it's a really tricky sum. And for this one, you don't get to choose. It's not an ABC like our usual hinge questions. And I won't see what you're saying anyway. Just have a little think for yourself. And then we'll talk about what she could have done in a minute. Okay, hopefully you've had a little think to yourself or a little talk about what Katie could have done instead. And I'm hoping that you remembered your rounding lessons. And there's a little bit of a hint down here. Although this is multiplying numbers and this is adding, I want you to see that you can do this for, you can use efficient methods for all the different operations, for adding, taking away, multiplying and dividing. So she had 3,999 to add to 2,999, and those are really quite difficult numbers to add together. So what she could have done is she could have said, right, 3,999, that's only 1 away from 4,000. So I'm going to pretend that's 4,000. And the bottom number is only 1 away from 3,000. So I'm going to do 4,000 add 3,000. And I can do that pretty easily because I know that 4 and 3 makes 7. So it's going to be 7,000. And then she just needs to think to herself, so the answer is 7,000, but I need to I added an extra one here and an extra one here. So I added 2 extra ones. So I just need to take those 2 extra ones off. And if she counts back a couple, she will know that it's that. She will be left with 6,998. Again, if that puts you in a jumble and a muddle, and you're really good at doing column addition, then that's fine. Do a column addition and just check the answer makes sense at the end and it is a decent answer and you haven't got something like 212, because that clearly wouldn't be the right answer to that sum. Okay, so I'm going to move it on to one last slide now. This is the platinum with you, but I wanted to show you them so that if you want to have a go at those as well, then you can. If you have any problems with those or any questions about them, then you can message us on Dojo and we will, or email, and we will see if we can help you with those. So the first one, it's just got Ron is calculating 46 multiplied by 4 using a whole part method. Can you explain Rob's mistake? He's made a mistake there. And then some of these are about how you would work out these sums. And it says explain to a partner, but obviously you can just think for yourself, or you can explain to someone at home if you have somebody there. Okay, so that's the end of your maths lesson today. And I will look forward to seeing you again on Monday. Have a lovely weekend. Bye-bye.